Hello everyone. In today's lecture we will discuss a particular example and we will take an ordinary differential equation and we will find the corresponding infinitesimals by using the least invariance condition that we have derived in the previous lectures. Now students, the ordinary differential equation is given as y double prime is equal to 0. Now we know that if we want to denote it in terms of delta, then we will write delta is equal to y double prime and set it is equal to 0. Now students, as we know that this is a second order ordinary differential equation, so we will use gamma 2. Means the least invariance condition is gamma 2 of delta at delta is equal to 0, that is equal to 0. Or if you substitute the value of delta, then you will get this term. Or students, you know that actually gamma 2 is equal to gamma 1 plus yxx into y partial by partial y double prime. Or more precisely, you can write it as gamma 1, that is capital X partial by partial x plus capital Y partial by partial y plus capital Yx into partial by partial y prime and plus capital Yxx into partial by partial y double prime. Now students, if you substitute the value of, basically you want to find gamma 2 of delta, or simply you can say gamma 2 of y double prime, because here delta is equal to y double prime. Okay, so you can write it down like partial by partial x into y double prime, because from here you can substitute delta here and in this way. Okay, so if you write the value of deltas over here, then you can write plus y partial by partial y into y double prime plus capital Y of x partial y double prime by partial y prime plus yxx into partial by partial y double prime into y double prime. Now students, you know that with respect to x, it is treated as a constant and this term is equal to 0. In the similar way, this is equal to 0, this term is equal to 0, and then you are left with yxx, because with respect to partial y double prime, its derivative is equal to 1. Okay, so that's why it is written here that yxx at y double prime is equal to 0 is equal to 0, because you know that here I have just find the value of gamma 2 of delta. Now the next target is to set it is equal to 0, means gamma 2 of delta at delta is equal to 0 is equal to 0, means our this value yxx that is equal to 0 under these conditions. Okay, now students, we also know that the extended infinitesimal transformations mean the value of yx and yxx is equal to this one, and in the previous lecture I have also derived the expression for yxx, and now our target is to set that value is equal to 0. Let me show it to you again. Means in the previous lecture we have derived the value of yxx that is equal to this one. Okay, now students, set it is equal to 0. Now the next target is to substitute your OD like the value of y double prime that is equal to 0. So this term will become equal to 0 after multiplying with 0, and this term also will become equal to 0. So you are left with this one. Now if we set the coefficients of y prime like this one, y prime square or y prime cube to 0 in equation number 2.17, then we will get what? We will get, means definitely we have to set the coefficient of y prime of 0. Okay, means because y prime of 0 is equal to 1, and actually it is a coefficient of y prime raised to power 0, because something power 0 that is equal to 1. Okay, so you can set here yxx is equal to 0, the coefficient of y prime, that is 2yxy minus x of xx is equal to 0, and then y of yy minus 2x of xy is equal to 0, and then the coefficient of y prime cube, and that is equal to 0. Definitely if you write minus over here, then it will become positive, because you can take it on the other side and after multiplying it with 0 it will become equal to 0. Now students, the set of equations that I have written down here that I have derived on the previous page, means these four equations determine an overdetermined system of equations for the unknowns x and y. Students, an overdetermined case is the case when the number of equations are more than the number of unknowns. Okay, Now students, integrating equation number 2.92d, means actually this is the equation number 2.92d, that is x of yy that is equal to 0. Now students, as you know, x is a function of two variables like x and y, and you want to integrate it with respect to y, then definitely what you will get over here, like if you integrate with respect to y first, then you will get a constant of the function x that is equal to, let's say you will write here a of x. Okay, and if you integrate it further, then you will get x of xy as a of x is treated as a constant into y plus the function of x, that is b of x. So that's why we will get over here the value of x of xy is equal to a of xy plus b of x, where a and b are arbitrary functions. Okay, now substituting 2.92c and integrating gives, what is the value of 2.92 c? This is the value, means y of yy minus 2x of xy that is equal to 0. Now students, if you want to find the value of x of xy, then what you will get? Actually this is the value of x of y, and if you will take its derivative with respect to x, then you will get a prime of x. Or if you write, you can also write it as y of yy that is equal to 2x of xy. And so if you substitute the value of x of xy, that is a prime of x, then you will write here 2a prime of x. Okay, and now if you integrate it with respect to y, then it will become equal to 2a prime x will be as a constant, and integration with respect to y plus the function of x, and again if you integrate, you will get the value of y as in equation number 2.94. Now students, here p and q are further arbitrary functions. Now if we substitute the value of 2.93 and 94, means these two values, into equation number 2.92b. Actually that equation number 2.92b is this one, means here we need the value of y of xy and x of xx. Then student, you will get this equation, and when we set the coefficients of y to 0, we obtain, means if we set the coefficient of y to 0, then here I will get the value of 4a double prime of x minus a double prime of x that is equal to 0, means you actually get this value now, 4a double prime of x minus a double prime of x that is equal to 0, and you will get 3a double prime of x, and if you take 3 on the other side, then you will get this value. Okay, and in the similar way, the when you set the coefficients of, you can say the y raised to power 0 equal to 0, then you will get these two terms that is equal to 0. Now students, substituting 2.93 and 94 into equation number a, and actually equation number a is this one, like y(x(x) is equal to 0, and you just need to find out the value of y(x(x), means the double derivative with respect to x. Definitely these are the functions with respect to x, so you just need to take the derivative of these functions that are equal to a triple prime when you integrate, when you take the derivative twice. So you will get a triple prime of x y square plus p double prime of x y plus q double prime of x, because you are taking its derivative with this 2 times. Okay, from which we obtain, like again if we set the coefficients is equal to 0, we will get p double prime of x is equal to 0 and q double prime of x is equal to 0. Now students, you can note one thing over here, that I haven't set the coefficient of a triple prime of x is equal to 0, just because in equation number 2.95 we got the value a double prime of x is equal to 0, and you know that, for example, if a double prime of x is equal to 0, or let's say if a prime of x, let's say this is equal to some constant, then if you take its triple prime, then definitely if you take further derivative, then these derivatives will be equal to 0. So there is no need to write this equation. Now students, the solution of 2.95 and 2.96 are simply as, like the equation number 2.95a and b are this one, and these two equations, means you have to integrate this term, or it is in terms of only a single variable, so there is no need to write the function of arbitrary function, like the constant of arbitrary functions, and you just substitute constants like a1 and a2 over here. Okay, So if you integrate a double prime of x, then you will get this one, p double prime of x, this one, and q of x is equal to this one, where these are constant. The remaining functions b of x is obtained from 2.95b. That is means now you can substitute the value of p prime x over here, and you can easily find the value of b of x. Now students, here you got the value of b of x. Now you know that from equation number 2.93 and 2.94, we need the values of a of x, b of x, a prime x, p of x, q of x. So we have found all these values, so you just need to substitute all the values in these two equations, and then after that, after further simplification, you will simply get this one, and these are the infinitesimals corresponding to the equation, that is y double prime is equal to 0. Students, you know, so far we have been discussing that if we are given the infinitesimals, then we can check the invariance of a given differential equation. But now the differential equation is given and we have found the corresponding infinitesimals. Now this is all about this lecture, and in the coming lecture I will discuss example number 2.18. So thank you so much.